Hello, Algebra 1 students. This is Chapter 2, Section 3, where we're going to be working with multi-step equations. So far, everything we've done just required one step. Now we're going to have to do at least 2 steps to solve our equations. Remember that when working multi-step equations, you work in backwards order of operation, the backwards order. So we'll add before we multiply or divide. We'll add or subtract first, then we'll multiply and divide. So it's the reverse order of operations when you are isolating the variable. Don't forget that. We're trying to isolate the variable. Alright, so here in example 1, it says to solve and then check our solution. M is my variable. I want M by itself. So instead of starting with dividing both sides by 7, there's something else happening to M besides multiplied by 7. We have a negative 17 or subtracting 17. So I take care of the subtraction problem before I take care of the multiplication. And whatever we do to one side of an equation, we must do to the other. So now I have 7M equals, and I have to add 17 to both sides, and that'll give me 77. Now I can take care of undoing multiplication by dividing by 7, and M equals 11. I think so. Let's check it. So 7 times 11 minus 17, does that equal 60? So 77 minus 17, that should equal 60, and it checks out. Alright. Now, 5q minus 13, so take care of the minus 13 by adding 13, undoing subtraction. So we're going to add 5q equals 50. Now I need to isolate q, divide to undo multiplication, and q equals 10. So let's go back and check. 5 times 10 minus 13, does that equal 37? 50 minus 13, it does give me 37, so it checks out. So some of you caught on that it's nice to just go back and highlight our answers, or I always have said to circle. So either way, either circle or highlight your answers is awesome. Help me find when I'm checking. Alright, here's another problem, but here t is being divided by 8 and adding 21. So we take care of that subtraction first, or the addition, undoing the addition. So t divided by 8 equals 14, and a negative 21, opposite signs I subtract and keep the sign of the larger. So that leaves me with negative 7. And now I have to take care of undoing division. So we multiply both sides by 8. That'll cancel because 8's understood over 1, and t equals negative 56. Let's check and make sure. Negative 56 divided by 8 plus 21, does that give me positive 14? That'll give me a negative 7 plus 21, so we will subtract and keep the sign of the larger absolute value, so it will turn out to be a positive 14, and it checks out. Okay, so add 9. That's a negative 11, so s divided by 12. Make sure we know that's an s and not a 5. Put a little tail on it. Negative 11 plus 9, I'm still going to be negative 2. Multiply both sides by 12. And s equals negative 24. Now let's check. Negative 24 divided by 12 minus 9, does that give me negative 11? So that's going to be a negative 2 minus 9. That is negative 11. Alright. Now let's get a little bit more advanced. The whole thing, p minus 15, is all being divided by 9. And that equals negative 6. So the first thing I need to do, I know I said do it in opposite order, but before I can take care of the negative 15, it's bound to p right here. So that whole difference is being divided by 9. So the best thing I can do is multiply both sides by 9. When I multiply both sides by 9, now I have p minus 15. It's unbound by that division bar. Remember, that's a grouping symbol. Equals negative 54. Now I can add 15 to isolate my p. And p equals negative 39. And we'll check. Negative 39 minus 15 divided by 9. Does that give us negative 6? Negative 54 divided by 9 is negative 6. I know you get tired of checking, but on a test you're going to want to check, because before you turn it in you should know whether or not you made 100. Alright, it's being divided by negative 3. No big deal. We just multiply both sides by negative 3. So r plus 8 is going to equal, whoops, that was supposed to be a negative 3. So two negatives, when you multiply two negatives, it makes positive when you're multiplying. And so that's going to be positive 6. I have to subtract 8. That's 8 is bigger than 6, and it's the negative. So I end up with a negative 2. Now let's check. Negative 2 plus 8 divided by negative 3, does that equal negative 2? That gives me a positive 6 divided by negative 3. So again, this is a positive negative, so in multiplication and division, a positive negative does not make me happy. It leaves me with a negative. It's like I'm half awake. I'm not very happy. So that's a negative 2, and that's what I wanted. My sign just didn't catch for some reason. So negative 2 equals negative 2. That is what we were hoping for. Alright, the last example I'm going to work with you on our video tonight is example 4. Write an equation for the problem, then solve the equation and answer the problem. 3 consecutive even integers. Find those whose sum is negative 42. Now, we need to talk about consecutive integers. 1, 2, 3. Those are consecutive integers. Well, if x is 1, what do I do to x to get 2? I add 1. Well, what do I do to x to get 3? Now remember, x is 1. So what do I do to 1 to get 3? I'd add 2. So this is what consecutive integers look like. You take the very first number and you add 1. The first number add 2. What if our consecutive integers were 11, 12, and 13, 3 consecutive? Well, if x was 11, 11 plus 1 is 12, 11 plus 2 is 13, 11 plus 3 would give me 14. That's consecutive. So over here on the side, this is if it said find consecutive integers. Make yourself a note somewhere. This asks for consecutive even integers. So I'm not going to be increasing it just by 1 each time. Instead, it's going to be, to keep it even, we have to take x and increase it by 2. Because if, let's pretend like we started with 2. Well, what's our next even integer? 4, and the next one's 6. So if x is 2, or an even number, and you add 2, then you get the next even number. And then we're going to add 4, because 2 plus 4 gives us 6. So even integers, this is what your formula should look like. So somewhere make a note, consecutive even integers. Alright, now while we're talking about this, let's look at consecutive odd. Now most people would think consecutive odd integers, if this is even, then it must be x plus maybe 1, x plus 3. That's what you would think. But let's test that theory. If I substituted 3 for x and I'm looking for the next odd, we know, because that's easy, we already know if x is 3, the next odd are going to be 5, 7, 9. Well, check your theory here. 3 plus 1, did that give us 5? No, it's 3 plus 2 that would give us 5. 3 plus 3, does that give us 7? No, 3 plus 4 gives us 7. And so to get 9, it would have been 3 plus 6 to get 9. So look what we just found out. To find consecutive odd or consecutive even, it's the same formula, the same pattern. Because go back and check. Let's erase and check. If I plugged in an odd number, let's say 7, and I need the next one to be 9, 7 plus 2 makes 9. 7 plus 4 makes 11, and so on. So these are some things you're going to need to commit to memory. If it's just consecutive integers, then it's plain old x, x plus 1, x plus 2, x plus 3. If it's consecutive even or consecutive odd, it's x, x plus 2, x plus 4. Now let's work the problem. 3 consecutive even integers whose sum is negative 42. So consecutive even, the first one's x, and it's the sum. Where did I read that? Here's the word sum. So it's x plus, the next consecutive is x plus 2 plus x plus 4. So now we're going to combine like terms. We have x, 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 so we have 3 x's, and we have 2 and 4, so that's 6 equals negative 42. So we'll subtract 6 from both sides. It was a negative 42. And so 3x equals negative 48. Divide by 3. And x equals negative 16. So then it said find the 3 consecutive integers. So now I have to plug it in. If x is negative 16, negative 16 plus 2, be careful, plus 2 makes negative 14. Negative 16 plus 4 makes negative 12. So there are 3 consecutive even integers. And so we're going up the number line, not down the number line, because we're adding 2 and adding 4. All right. So I'm going to set up this next one. I'm going to let you solve it on your own. Find 3 consecutive odd integers. It's the same setup, people. X, x plus 2, x plus 4. We already talked about why that's odd integers. If you missed it, we'll talk about it again tomorrow. Equals, and I've covered it up here, but I think it's 57. So there's the setup. See if you can find the 3 consecutive odd integers. I'll be checking that one tomorrow. So be careful, and here's a little joke to end the day. What did 0 say to 8? Do you know the answer to that one? See if you know. 0 and 8, they were talking. What did 0 say to 8? Ha. Have a good day.